This is the question where we have composition of function. Composition is one function is going to eat the other function. One function gets plugged into the other. So the way I look at this, G composite H, the closest one to the X is going to go inside the G. Another way to look at this is it's G of H of X, right? These is a way to translate composition. So the H function is going to go into the G function. What I like to do is start with the outside function, the G function. So I'm going to get it set up and ready to go. So G of X. But notice if you put an X in here or something, there's something in there, right? I guess I could have just stayed with that one. So I'm going to take this G function. I'm going to rewrite it. And I'm going to make the X a new symbol. The new symbol is just a big open parentheses, so I can put stuff in there, right? So I'm going to do this as the square root of 3x plus 18. So I've made a template. What goes in here? Well, h of x goes in there. What is h of x? It's this, x minus 5. So wherever that opening is, there's x minus 5. Now, can we simplify that a bit? Sure. So this is g of h of x. We can do the square root. We can distribute this 3. That gives us 3x minus 15 plus 18. And we can do this arithmetic, and you will need to. Alex is not going to be very nice to you if you don't finish this up. It's going to be 3x negative 15 plus 18. That's going to give us a positive 3. And that's good. That's how it is. That's how it should be. So that's going to be our answer for the function. 3x plus 3. Now what about the domain? Well, remember, with square roots, we cannot, the thing that causes problems is having a negative inside of a square root. That's an imaginary number. It's not a real number. So what we're going to do is we take the inside, I like to call it the guts, of the square root. We take the 3x plus 3, and we know the domain is everything that gives us a positive value. That means it's going to be greater than or equal to 0. 0 is a positive number, or, well, it's a non-negative, let's put it that way. We won't get into that discussion because we could take either side and probably both be right. So we subtract 3 from both sides. We get that 3x has to be greater than or equal to negative 3, and then we divide by 3. So we're getting our domain that x has to be a number that's greater than or equal to negative 1. Now x itself can be negative, but when it gets plugged in here, it's got to be 0 or bigger. And again, what I like to do with intervals is I like to do a number line. There's the left side is negative infinity, the right side is positive infinity. This is our boundary place, our negative 1, so I can put it anywhere I want. Just put a little marker there. It is included, so I'm going to put a nice, I'll do it in a different color, a nice solid dot. And then x is bigger than this, so that means it has to be to the right. So we get the shading the right way. The nice thing is, I know it's included, so that's going to give me a bracket, put a comma, and notice I'm actually getting my interval right here on the number line, and I get it all in the right order. Okay. So let's put that in here. A bracket on one side and a parentheses on the other. Negative 1 to infinity. And there we are. We've got it all taken care of with this composition of function. But do take the time, but that change the x to a big parentheses. That's a good symbol to use for inputs, right? And then we're all okay from there.